Hello, everyone. It's an absolute pleasure being in Lindau with the Nobel laureates. Keratoconus sounds like a good buzzle word, isn't it, to use? Keratoconus. But to many eye doctors, this is a frequently encountered, visually disabling eye disease. Many eye doctors live to conquer this disease because it has a lot of, or huge burden on patients and societies. I think, though, we do have a solution. Keratoconus is a disease of the cornea of the eye. The cornea of the eye is the most front part of the eye. It's a transparent membrane. It lets light go through, as well as protecting the inner structures inside the eye. It's like the windshield of a car, basically. This cornea is normally a section of a football, or spherical and smooth-shaped. But in this disease, it becomes conical shaped, becomes like this, basically. So when light goes through, it scatters, it goes all around, and these patients have visually disabling sight. This disease has been linked to a lot of eye rubbing, as well as allergic eye disease, but these do not explain the whole story. This disease is problematic for a number of reasons. One, it's the #1 indication for corneal transplantation in many parts of the world, and it's second worldwide. In Germany, it's still a very important indication for corneal transplantation. Second, this disease affects people from the ages of 10 to 30 years old. As we all know that this age group is a vulnerable age group. We acquire education, form our personalities and relationships during this age group. And we have seen a lot of patients who commit suicide with this disease. Third, these patients present to us quite late in the course of their disease, leaving us with no choice but having to transplant them with new corneas. Leave aside the many hospital visits they have to make and the complications they might get from having a new cornea. So it would be prudent to think of how can we detect this disease early in the population. At the moment, to detect the disease early, we need a large, cumbersome, and expensive tool called tomography. It costs about 80,000 euros. It's available in specialized clinics, but it's not available everywhere, and it's not available in low-income countries. But there is another simpler tool called the retinoscope. It's been used for hundreds of years in ophthalmology or in the eye diseases clinics. But no one has actually examined it, whether we can detect the disease early in the population using this small, accessible, and cheap tool. It costs about a few hundred euros. The tool is very simple, actually. It projects light in a certain way to the eye of the patient, and we just move it from one side to the other. And we see a reflex doing like this. It's called scissoring reflex. So if we see the sign, it means that this patient might have the disease. If we don't see the sign, it means that this is an absolutely healthy cornea. So what we've done is we got 123 patients. This gives us 246 eyes. And so we examined these eyes with the retinoscope, and we examined them with this large machine. It's called the tomography. We were thrilled to find that we can identify 98% of these patients with this simple device. So the next step is actually to go out to the population where the disease is quite frequent. We'll go to schools, to universities where patients or where individuals are susceptible to this disease, and screen them with this simple tool. If we see the sign, we'll bring them into hospital. Now, if we bring them into hospital, if we detect the disease early, we do have treatments to stop it progressing. So if we treat it early, we don't have to transplant them with corneas at the end of the day. Thank you so much.